Math 7 Unit 8, Lesson 4, Part 2. In this, we'll go over the sampling methods and look at some examples of different sample types and conclusions. This is the second video. Please watch the first video if you haven't already that explains bias and validity and the sampling methods. Okay, for the results of a survey to be valid, an unbiased sample is selected so that it's representative of the entire population. So determine whether each conclusion is valid and justify your answer. To determine what kind of movies people like to watch, every 10th person who walks into a video rental store is surveyed. The store carries all kinds of movies. Out of the 180 customers surveyed, 62 said they prefer action movies. The store manager concludes that about a third of all customers prefer action movies. Now the conclusion here is that a third of all customers prefer action movies. So our population is actually customers, it's not all people. If it was all people, this wouldn't be as good. But since it's customers, that's actually a pretty good conclusion. I'm going to go with yes. The conclusion is valid because the population is the customers. Each customer that came into the store that day had an equal chance of being chosen. Anyone could have been that 10th customer. However, there are some potential issues here. What day of the week did the manager conduct the survey? Different days of the week could lead to different people coming into the store, so that might have an effect. Okay, let's look at the next one. A television program asks its viewers to visit a website to indicate their preference for two presidential candidates. 76% of the viewers who responded prefer candidate A. So the television program announced that most people prefer candidate A. Alright, well, what I'm seeing in here is that you have to voluntarily go to the website and choose to fill out the survey. And a lot of people aren't going to do that. So this is not a valid conclusion because the sample represents a voluntary response sample where those who want to participate are favored and those who do not want to participate would not be favored. To determine what people like to do in their leisure time, people at a local mall are surveyed. Of these, 82% said they like to shop. The mall manager concludes that most people like to shop during their leisure time. That'd be a great thing for a mall manager to find out. That means more business for him. However, I do not think it's valid. It's not valid because those who like to shop in their leisure time would be at the mall and would have a greater chance of being surveyed. The sample is biased in favor of shoppers. That says or, that should say of shoppers. That's okay, just pretend it says of. So on this, that's actually a convenience bias, a convenient sample, because it was convenient for the mall manager to go out where he works or she works and interview people there. Example 8:17. To determine what kind of sport junior high school students like to watch, 100 students are randomly selected from each of the 4 junior high schools in the city. Of these, 47% like to watch football. The superintendent concludes that about half of all junior high students like to watch football. Okay, a big helpful thing here is that it's randomly selected. So yeah, I'd say each student has an equal chance of being chosen, so it tends to be a good conclusion. Unless there are some potential biases that can creep in here. There's 4 junior highs in the district. Are all 4 of those junior highs the same size? If they are, then this is great. This will work. But if they are different sizes, this can be problematic. Let's say one junior high is rather small, only has 200 students. Another junior high is quite large and has 1,000 students. Well, if you're at the small junior high, you have a 50% chance of being chosen. But if you're at the large junior high, you'd only have a 10% chance of being chosen. So that survey would favor, it would give more voice to the students at the small junior high. If the junior highs are different size, you'd want to do the same percent of each junior high. But that's a place that you can potentially get this to not work. But on its face, it seems to be pretty good. Let's look at the next one. To evaluate their product, the manufacturer of light bulbs inspects the first 50 light bulbs produced on one day. Of these, 2 are defective. The manufacturer concludes that about 4% of light bulbs produced are defective. Now, 2 out of 50 is 4%, so they did the math right. However, let's look at the sample. The first 50 light bulbs of the day. Well, that would be nice. You'd have all your sampling done right at the beginning of the day. That's actually quite convenient. So no, the sample represents a biased convenience sample. 50 bulbs were chosen that were easy to access. The machine may not operate at the same level after it is warmed up as it does at the beginning of the day. It is possible that after it gets warmed up, you get fewer defective light bulbs, or maybe after it gets warmed up, you get more defective light bulbs. We can't know for sure. This would be better if they were to select a bulb every 20 minutes. Well, let's see, if you wanted to select 50 throughout the day. If you select one every 10 minutes, that's 6 per hour. They probably could do something like that. 8 hours would be 48 bulbs. They just do a couple more somewhere throughout the day and just randomly select them throughout, and that would be much better sample. A survey is to be conducted to find out how many hours students at school spend on the internet each weeknight. Describe the sample and explain why each sampling method might not be valid. Okay, so we're trying to say what are the problems in each sample. 10 randomly selected students from each grade level are asked to keep a log during the winter vacation. Well, I can think of a couple things wrong with this. Extra homework over the winter vacation. It's a voluntary response sample. The students might not complete the log during the break. Big surprise there. Another thing, which I think this is pretty important too, also, students might use the internet more during the winter break than they would on a weeknight. It did say that it wants to know about internet use on weeknights. I assume that means school nights, and over winter break, even though yes, they're during the week, they're not your typical weeknight if you're trying to gather good data. Next, randomly selected parents are mailed a questionnaire and asked to return it. Now, one thing here, the parents are probably more likely to complete the questionnaire than the students would be to finish a log. However, there's still problems with it. It is a voluntary response sample. Parents might not complete the questionnaire. Also, another important thing to realize here, parents might not be fully aware of the amount of time their teenagers spend on the internet. It could be that their parents underestimate the time. They think that you spend 2 hours a day, but you actually may spend 4 or 5 hours a day. It could go the other way as well. Parents might overestimate the time you spend on the internet. Let's say that you actually spend 2 hours, but your parents think that you spend 5 hours. So it may be inaccurate based on a variety of things, of parents not being fully aware of the amount of time their teenagers spend on the internet. Now, if you have something like screen time where they can just look it up on a device and figure out how much time you've actually been interacting with that device on the internet, then they could give some pretty good data. All right, example 821. A questionnaire is handed out to all the students on the softball team. Well, that sounds pretty easy to do. You go to a softball practice, you hand it out to all the team members and have them fill it out. A couple of problems with it though. It is a convenient sample and it's a voluntary response sample. The students are selected because they're easy to access. You can get them at softball team practice. Also, you are relying on them to return the questionnaire. They also might spend a different amount of time on the internet than the average teenager. Maybe because they're involved in the softball and they might be involved in some other team things, they may not spend as much time on the internet. But you know, if they have the internet in their hand on a phone, they might spend a lot of time anyway. So remember these 3 types of samples. This is just copied over from the previous video. And in your practice, on number 1, you're just telling me if it's biased or unbiased and explaining why. There always is going to be a little bit of bias, but if it's minuscule, then it's okay to call it unbiased. You don't have to try to find every little tiny problem with it. If it's pretty good, call it unbiased. The second one, you're determining whether a conclusion is valid and explaining. On 3, you get to do the mean, median, and mode. 4, you got to solve an equation. Number 5 is doing a problem with histogram. Number 6, determine the area and circumference of a circle. Number 7 deals with samples. One thing to remember for 7, if you have two different samples that are both gathered the same way, the one with more people in that sample will be a better sample. The one with more elements in the sample. And then number 8 gives you some situations and asks how you could reduce the bias in the samples. Thanks for watching.